everyone. Welcome for the podcast for synthetic division. And so with synthetic division, we spent some quality time already talking about long division. So now we're going to be talking about synthetic division. And with synthetic division is just a different style. And again, if you kind of look at some of the similarities, you'll kind of see where they're a little bit similar to each other, but yet different. So in number 3, if you recall from the day previous, we were talking about long division. And so we were putting in our polynomial and then putting in what we were dividing by. And so we were thinking about m times what makes m squared. And so m times m would make m squared. So then we multiply down m times m, which is m squared, m times 2, which is 2m. And we're subtracting. So be careful here, though. We're going to have negative 3 minus 2. And so what's going to happen here is we're going to have negative 5m. So now we're going to think, what am I going to multiply m by to make negative 5m? Well, I've got the m, but I need to multiply by negative 5 to get that. So multiply down negative 5 times m, which is negative 5m. And, oh, by the way, I forgot to bring down the minus 7, so quick sneak that in there. Negative 5 times 2, which would make negative 10. And subtract, and these drop. Negative 7 minus negative 10 becomes negative 7 plus 10, which is 3. And so that's my remainder. So positive 3 over m plus 2. And so that's what we learned yesterday. Now, when we're looking into synthetic division, it's kind of the same idea, but a different style. And you'll kind of start to see the same numbers that we had before. So in synthetic division, the first thing you do is you take the polynomial that you have that you're going to be dividing, and you think about the numbers that are in front of the letters. And so I'm going to put a 1 in front of the m squared. And so we're just going to write the numbers that are going to be there. And so we have a 1, we have a negative 3, and a negative 7. Then next, we're going to divide that by our magic number. And so the magic number is right here from this part. And so we're going to say, okay, if m plus 2 equals 0, what number am I really dividing by? Well, I'm really dividing by negative 2, because that's going to solve this equation. I'm going to subtract 2 both sides. So in synthetic division, we drop down the first number. And according to our rule and algorithm says now we're going to multiply. So we're going to do negative 2 times 1, and that's going to give me the number that's going to leapfrog into here. So negative 2 times 1, which would make negative 2. And then we're going to add. So we're actually doing the opposite of what we were doing before. But notice how I'm still getting that negative 5, which is matching this negative 5 over here. So that's not really life-shatteringly new. And then we're going to follow the process again. Now I'm going to do negative 2 times negative 5. And then that number is going to pop up here. So that's going to make positive 10. And now we're going to add. So negative 7 and 10 make 3. And that's my remainder. And so now I've kind of got the same numbers. I mean, I've got a 1, I've got a negative 5, I got a 3. So I can see over here, I'm getting kind of the same information as here. Now we just have to write down what the answer is. And so when you look at your original polynomial, you are taking away an m from each term because it's going to be 1 power less than what you had. So therefore, this tells me I'm not going to be at 1m squared. I'm going to have just 1m. This one's going to have no m, so it's going to be minus 5, and then plus 3, and then over what I divided by, m plus 2. So again, I'm still kind of getting the same numbers. It's just that it's a different style of doing it, and you're going to get the same answer. And so that's kind of what you're looking at. Number 4 is here another example of synthetic division. This time I'm just going to jump right into synthetic because you've seen enough examples of long division. So to repeat the process, we write down the numbers, and it's so important that they're in order. 3 x's, 2 x's, 1 x, no x. By the way, if it's ever missing a position, you would need to put 0 for the missing position because otherwise it's not going to be sequential and it's not going to work in synthetic division. In the magic box, we'll go, again, x minus 2 equals 0. So the number in the magic box will be 2. Again, in the algorithm, bring down the first number. So again, we're going to be doing some multiplying. So we're going to do 2 times 3, and then that's going to pop up. So that's going to give me 6. Add down. Then again, I'm going to do 2 times negative 2, and then that's going to pop up. And so that's going to give me negative 4. Add. So that'll give me 1. And then finish the process 2 times 1, which will give me 2. and then add. This again is my remainder. And so now here's my answer that's right around this region. So I got to figure out what that means. Well, if I started with x cubed, each one of my x's are going to have one less x now because I'm dividing by x minus 2. So therefore, it is going to be a 3 here, but it's not going to be x cubed like here. So it's going to be 3x squared, then minus 2x plus 1. And then again, the remainder is positive, so plus 1, and then what I divided by, x minus 2. So again, synthetic division is just a different style of doing long division. And again, we could go through more examples and so forth and give you a general idea of those. I wanted to do this example instead because this example is really important because with this example, you're going to have to deal with zeros. And so I think that's really important. So we're going to go through 6 and 7, and then we'll stop, and then that will conclude this podcast. So for number 6, what we're going to do is if this is x to the 4th minus 81, we're really going to have a 1 for the x to the 4th, but we have a 0 for the x cubed, a 0 for the x squared, a 0 for the x, and a negative 81 because that's the no x. So you have to keep those. You need the zeros in there or we're going to have an issue. Again, x minus 3 equals 0. That's going to give me my magic number, which is going to be 3. Okay, bring down my first number. And again, we're going to do 3 times 1, which is 3. Add down. 3 times 3, which is 9. Add down. 3 times 9, 27. Add down. And 3 times 27, which is 81, which makes 0. So what do you think that means if there's a 0 in the remainder box? Well, hopefully you know that means there's going to be no remainder. So we don't have to worry about it. Now, remember, the highest power here was x to the 4th. So when I look at this 1, that doesn't mean I'm going to have x to the 4th anymore. So now I'm going to have 1x cubed because it's 1 less x. And then continue down. 3x squared plus 9x plus 27, and there's no remainder, so that's my answer. And there again is my synthetic division. Okay, last problem that we're going to do for this particular podcast. Again, the same idea as before. We're going to have a 1, a negative 2. Notice there are no x squared, so that's going to be a 0. And then 1 and a negative 1. And then in the magic box, again, x plus 1 is going to equal to 0. So we're going to solve that by subtracting 1. And then bring down the magic number of 1. So we're going to multiply negative 1 times 1, which is negative 1. Add, we'll get negative 3. Negative 1 times negative 3 is 3. And add, we'll get 3. Negative 1 times 3 will make negative 3. Add these, we'll get negative 2. And negative 1 times negative 2 is 2, and we're going to add. In this one, we have a remainder of 1. So remember, again, it's x to the 4th, so we're taking off 1 power from each term up here. So we're going to have 1x cubed. Now go consecutive down, minus 3x squared, plus 3x, minus 2, plus 1, because that's my remainder, and I divided by x plus 1. And so that's kind of the short essence of synthetic division and what you can do with it. And so if you have any other questions, you can ask. One thing that we could also talk about is how we could use any polynomial and we could use synthetic division to help us find the zeros and so forth. But that's going to be covered a little bit more in pre-calc, and so we'll kind of leave that alone for the day. So have a great day.